In particular, we're going to look at finding the limit of a sequence. So here is a sequence. There are a number of techniques we are going to do, or one of the techniques we could use is L'Hopital. We could use brute force, so I'm not putting them in any particular order today. And we could do the divide top and bottom. By, well, it's whatever you need. Typically, you divide the top and bottom by n squared or n cubed, but you're going to see some different versions of that method being used. So I want to find this one. If I do brute force, 5 to the infinity and 1 plus 8 to the infinity gets me the dreaded infinity over infinity, which is indeterminate form, so that method didn't work. L'Hopital is a good go-to method. It works a lot of times. And can you trust me, in this case, it doesn't. All you end up with is just an uglier version of the thing you're looking at. And you never get anywhere. It just kind of goes around in a little circle and nothing happens. So it means I'm left with a technique that you haven't maybe used in this situation, but it works. I'm going to divide the top and bottom by something. And it's not n or n squared, because there aren't any n's or n squares floating around here. I am going to divide the top and bottom by 5 to the n. Now, as long as you do it to both, it's allowed. Now, you might think, why 5 to the n and not 8 to the n? Right. Whenever you have a choice, do you know how sometimes you have a question and it's a fraction and there's an n squared in the top, but there's an n cubed in the bottom, and you say, well, what do I divide by? The rule my rule for that situation is divide by the smaller choice. So that's why I picked 5 to the n and not 8 to the n. Could you do 8 to the n? Yes, but sometimes the math looks really weird if you try that. It tends to be nicer looking if you pick the small guy. So let's see what happens when I use that method on this particular question. Well, you get 1, which is always nice. You get 1 over 5 to the n, okay? And you get 8 over 5 to the n, right? So far, so good. Now, we're going to do some brute force stuff here. I'll just do these guys separately. Won't this guy be 1 over 5 to the power of infinity? And would you agree that's the same as 1 over infinity? Would you agree that's 0? Are you happy with that one? So I got a 1 on the top. That guy gets me 0. Now, this one's a little bit sneaky. What you have to do is you have to imagine that guy, right? So it's not 8 to the n and 5 to the n treated separately. Do you see I've stuck them together as 8/5 to the power of n? Now, if this number, and it is bigger than 1, what do you get if you take a number that's bigger to 1 and raise it to the power of infinity? Okay, so what do you get if you take a number that's bigger than 1 and then take it to the power of infinity? What's the answer? Like 2 to the power of infinity, 1.1 to the power of infinity. What do you get?
It just keeps getting bigger.
Right. And we call getting bigger, don't we call that an infinitely big answer? So that guy gets you 0, that guy gets you infinity. Isn't 1 over infinity 0? Are you happy about how we figured out the limit of that particular sequence, right? How about this one? The limit as n tends to infinity. So we're looking at the weirder ones now. 4n over n plus 1. Now, for this one, I'm going to change the order. I'm going to find e to the power of the limit as n tends to infinity of 4n over n plus 1. And you are allowed to do that, right? So if somebody has the sine of an ugly thing, e to the power of an ugly thing, right? The square root of an ugly thing, you can do it, yeah, right? You can move the limit around. This guy here, would you agree this guy here you could probably do in your head? Would you agree the limit of 4n over n plus 1 is going to be 4? Now, if you wanted to prove it to me, couldn't you divide top and bottom by n or L'Hopital it? But would you agree it's 4? So the answer to this one is e to the 4. We cool about that one? How about this fella then? I'd like to know the limit of this sequence. You've got to have a kind of strategy here, right? It has to be one of these three guys, right? That's the only kind of toolbox I've got to pick from. Would you agree right now it's probably a good idea to do some algebra to it, some style points if you prefer, and then decide the method? Any suggestions about how I could rewrite this fella?
Put e to the 2n on the bottom.
Agreed. When you see a guy that looks like that, which one of these methods comes to your mind? Which of these three techniques here would you use on this question? What do you think is a natural one to use?
L'Hopital's.
A L'Hopital. Doesn't it have that kind of fraction look where the top and bottom are both infinite? Now, if I do L'Hopital on this one, I get 2n on the top at least. On the bottom, because there's a little chain rule, I get that. And it doesn't work, but that's okay, because I can do L'Hopital a second time. And actually, technically, shouldn't I cancel those twos just to make my life easy? And I now get that guy. But when you plug in infinity, hey, it converges to 0. Are we good? By bad luck, I haven't got one, but can't you imagine sometimes the answer is going to be infinity? You know, the limit is infinite. And when that happens, don't you just say diverges? You know, so there will be questions where the limit is infinitely large. This guy is deceptively weird. Any suggestions about how I would tackle that question?
Could you combine the natural logarithms to be n divided by 4n? No, n minus. Would it be minus?
No, but I kind of think I know what you're talking about. You would do that if it was a log n, take away a log of 4n, right? If it was a situation that looked like that, you would do that. But two logs divided, there is no algebra that you can use. They're kind of untouchable, right? You can't do anything to them in that way. What method works for this? I don't need to change it algebraically. What works?
Would you divide by the log of n?
No, not this time. I can see what you're thinking. You know, get rid of one of them. No, don't need to do any algebra. I just need to do one of these guys. Well, I guess you're describing step 3. So
You can just L'Hopital.
it's a L'Hopital.
And it'll just be like 1 over n over 1 over 4n, I think.
Yeah, almost. Right. This guy is going to be 1 over n. And when you do this guy, you get 1 over 4n, okay, times n, times 4, I should say. So what do? You get the limit as n tends to infinity of 1 over n over 1 over n. Oh, the answer's 1. Isn't that deceptive? I mean, you look at the question and think, what am I going to do? Well, it's actually just L'Hopital. You can overthink a question, right? Now, since you brought this one up, I think it was Kira that brought this one up. Let's show you one where you could do some manipulation. In fact, you should. Suppose I was asked to find the limit of that sequence. Then in this situation, we should combine them. What do you get if you subtract 2 logs and you put them into a single log? What's the subtraction of 2 logs give you?
You divide them.
Division of the arguments.
Right. Agreed? You divide them. So far, so good. Now, in this case, I would do that next. Yeah. Log of ugly thing, right? The limit of a log becomes a log of a limit, right? You're allowed to switch the order. I hope you can look at that and just tell me what number this limit would be. What would this fraction be? As n becomes infinite.
1 over 2.
Yeah. So your answer would be the natural log of a half. Or if you're being really pernickety, it's negative log 2. And if you're wondering how I did that, well, I could call it the natural log of 1, take away the natural log of 2, which is 0, take away that guy, which is that fella. I could have done it this way, I guess. 1 half. I could have called it 2 to the power of negative 1, and that became negative log 2. I mean, there's lots of algebra ways to do it. I'm hoping that WebAssign would be happy with that. I think log of a half is, style points is pretty good. Are we cool on that? A little bit different. It still ends up being, technically speaking, isn't that a divide top and bottom by n squared, which is where the half came from. So we do eventually use one of these, although there was a fair amount of algebra before that happened. Here is one that none of those methods work for. At least not directly. Can you trust me that if you do L'Hopital and that, you'll just get a sore head and not very nice answers? So forget L'Hopital right now. If you do brute force, you could probably do it with brute force. Changing my mind now. Okay, let's do brute force. Cos squared of infinity over 3 to the power of infinity, right? Let's see if I can argue this. Would you agree that 3 to the power of infinity is infinitely large? Would you agree the bottom's infinite? Now, cos squared infinity, I'm going to do a kind of pseudo real, not a very mathematical argument, but I'm going to use it anyway. Would you agree that you don't know what the cosine of infinity is, but don't you also know that it's not going to be any bigger than 1? So won't cos squared not be bigger than 1? So won't that top thing be a number less than or equal to 1? Right? It's going to bounce around. What's the answer to a number that's less than 1 divided by infinity? And it doesn't matter what the number is, it's just less than 1. What would a half over infinity get you? 0.99 over infinity get you? What do they all get you? Because they all get you the same answer. Big fat 0. Would that argument work for you? Does it make sense why I would be able to kind of do that as a judgment call? Now, the method that they're really wanting you to do is a sandwich thing. Which is kind of formal version of what I just said. The top is somewhere between 0 and 1. The limit of this side is 0. The limit is n tends to infinity. Tends to infinity is this side. So the limit of this guy has to be 0. And that would be the way of showing that using what's called the sandwich theorem. Any questions? Are we good? We're coming pretty close to the end of these. There's still some weird ones to do. How about the limit as n tends to infinity of n over 2 times the sine of 2 over n? Doesn't really lend itself obviously to any of these 3 techniques, yet it is going to be L'Hopital. First thing I'm doing is just tidying up. This n over 2, isn't that another way of saying a half n? And since it's a constant, can't I just pull it out to the side and get rid of it? And now I'm going to do the sneaky one. I'm going to write it as a fraction. If you prefer. If you like that, it's the same thing. Now that I've written it in this form, can you see that it's been structured so L'Hopital can be used? So let's see what we get. When you do L'Hopital, you differentiate the top, so that's the cosine of 2 over n. You then differentiate, because it's a chain rule, 2 over n, and you get negative 2 over n squared. And then you differentiate the bottom, and you get negative 1 over n squared. And this guy cancels out partially with this guy, and this negative cancels out with that negative, and so all you're left with is that guy. And now I can brute force it. It's 2.5 times 2, the cosine of 2 over infinity. They cancel, and you're now left with the cosine. 2 over infinity is 0, and the cosine of 0 is 1. So in this question here, the trick was to realize that it had to be L'Hopital. None of the other methods was going to get me anywhere. I did a little, I guess I don't need to do that with a half. You could have lived with it, but I just took it out because it was distracting me. Take it and write it as a fraction. So if that was n cubed, wouldn't I call this 1 over n cubed or n to the negative 3? And then I can do L'Hopital, and then I do some cancelling. Basically, these 2 cancel and leave you with 2. And then I can do brute force, and I got my answer.
Wait,
Yes.
Is it in indeterminate form before you do L'Hopital?
Um,
Doesn't it have to be in indeterminate form?
okay, let's go. 2 over infinity is 0. Sine of 0 is 0. 1 over infinity is 0. I have a 0 over 0. It is indeterminate form.
Okay.
And you're right, it has to be an indeterminate form or you can't use L'Hopital. It
Okay.
might not look like it is, but it was in fact an indeterminate form.
Okay. Thank you.
Now, there are going to be questions where there is no method, and let's show you one. And by the way, this is a version of 35. So this bunch of questions are all going to be intuitive. 5 times n factorial on the top, 2 to the power of n in the bottom. I know it's a fraction and therefore your go-to guy would be L'Hopital, but this last bunch of questions are not going to be any of these methods. These are going to be just one-offs, intuition, mathematical common sense, whatever you want to call it, is going to be your friend here. In these kind of questions, almost all of them except one that I'll show you right at the end, it's going to be that kind of thing. So go for it. What do you think that limit is?
Infinity.
I think it diverges.
So it diverges. Anybody want to give me an insight? You're right, it is. Why you thought that? Because there isn't a proof, right? You can't use this method, right? What do you think, Matthew? Why?
Because with factorial, you're essentially multiplying like 5, 4, 3, 2, 1, and with 2 to the power of n, you're just multiplying 2, 2, 2, 2, 2, 2.
Right. So if I can paraphrase what you're saying is n factorial is much bigger in the long run than 2 to the n would be.
Yes.
Yeah. That's a good approach to this type of question. So let's do a little list of who's better than who, right? So we can compare them. Right over at the what, is n factorial. Would you agree n factorial is huge in the long term? But there is a guy who could beat him. Would you agree n to the power of n would be even bigger in the long run? Then we need to do 2 to the power of n and then n squared. Let's talk about these two guys. Why is 2 to the power of n going to be bigger in the long run than n squared would be? What's the thinking behind that one? Because it's true. Can you imagine why it might be true?
Because
Hmm?
n isn't limited, whereas the 2's you can only square the term.
Right. So if you were looking at this guy, if you were doing a n as 1,000, wouldn't 2 to the power of 1,000 be ridiculously big? In fact, 2 to the power of 1,000 is, I think 2 to the power of 1,000 is so big, there's not enough paper in the universe to write down what it is. Right, that's how big it is if you wrote it down. Wouldn't 1,000 squared just be 1,000,000? Can you imagine? So if you're not sure about a number, couldn't you just pick a big number like 1,000 and figure out what each was and the one that wins? After these guys, would you agree the square roots and the cube root guys, would you agree that they get big, but don't they take a long time? They're not really getting big very easily, right? So that's a pretty slow moving function. There's another function in this list, basically the last one. Who gets bigger even slower than the square of n? Who takes a heck of a long time to get big?
Logarithm.
Yeah. So if I gave you a combination of 2 of these guys in a fraction, and I said to you, 2 to the n over n factorial, for example, Wouldn't you say this is going to be massively bigger than that guy in the long run? And so your answer would be 0. If I switch places, wouldn't the answer be infinite, right? Diverges. In these kind of questions where you're picking two, one to go in the top and one to go in the bottom, would you agree that all you need to do is figure out who's going to win and that tells you the answer, right? If the thing that's going to win is on the bottom, don't you get 0? And if the thing that's going to be massively bigger than the other is on the top, aren't you going to get infinity? And that's the only, you're not going to get numbers in these combinations. Now, that's not a proof. Would you agree? I'm just saying that it's just intuition, right? Things are bigger than other things in the long term. Okay, so I guess I could do one of these guys. What the heck? Well, 2 more. What would happen in that case? Just intuition using this. What would happen here? Is the -2 disturbing you? You know, it's the same answer even if it was 2 to the n. Matthew, you said 0 or showed me 0. Would you agree that n factorial wins? It's massively bigger than the other guy. Massively big on the bottom means the answer is 0. If it's massively big on the top, the answer is infinite. You do not get any numbers, right? There's nothing in the middle. It's either 0 or infinite in this case. How about this sequence? It doesn't even have a formula, but it definitely has a pattern. No tests, just pure intuition, pure mathematical common sense. What do you think we would describe the limit as n tends to infinity of this sequence?
Would it be undefined because just kind of like cosine, it oscillates back and forth, so we never know where it's going to land at any given moment?
You said it much better than the way I was going to say it. Yes, it's undefined. And the way Kira said it was nice and clear, so I'm not going to waste it and try and do my version. Well, we got a few bits and pieces. I think I'm going to pick these ones out of the hat. Where's the first one? This is, I'm about to tell you something that's true, and I'm making no attempt to prove it. The limit as n tends to infinity of 1 plus any number a over n raised to the power of b over n. That is equal to e to the power of ab. Will you just trust me that that is true? Right? I am a mathematician. If I tell you it's true, it's true. If you want to get a proof of it, you could go online and look at definition of the exponential function, and you might find someone describing it in terms of this. So, since I'm telling you that this is true, we can use it to answer this question. What is the limit of 1 plus 2 over n raised to the power of 3n?
E to the 6th.
Now, do you see that you're just doing that because I told you what it is, but that's totally fine. That's how you get the answer to that one. Would you agree this is a very, very specific situation, right? Nothing else looks like this. You only use it in this one very limited context. What would that one get you?
E.
E. Okay, now I cannot prove that to you because, well, one day if you, well, how am I going to phrase this? One day you will prove it. If you do enough math, you'll go to a class where we'll actually show you why that is the proof. But for right now, it's just trust me, right? But I'll do my best. I said that the limit of this is equal to E, okay? So let's find out what E is, at least as far as this calculator is concerned. E is 2.718222, blah, blah, right? Now, if this had a limit of that, let's put a big number in. 1 plus 1 divided by 1,000 raised to the power of 1,000. Would you agree that that's a pretty well into the sequence? Shouldn't that answer be darn close to E? Okay. I'll break the calculator because 1,000 is maybe too big a power. If not, if I do that, I'll make it 100 the next time. But here goes. Would you agree that 2.71 is actually getting pretty close to being E? Should I do 10,000? Shall I try and break it? Yeah, let's try and break it. 1 plus 1 divided by 10,000 raised to the power of 10,000. 2.7181. You know that's not a proof, but it's at least convincing you that this piece of magic works. Right? And you could do it for that one there if you wanted, and you'd see that it became something close to E to the 6 eventually. I don't like magic, but sometimes you have to have it. And since we're having magic today, here's the second and final magic. That is actually equal to a number. So you might have thought it was infinite, but it's not. Any guesses what number that is?
1.
Yeah, your intuition was right. It is 1. I'm not even going to attempt to prove it, right? But will you trust me, it is. There isn't any homework questions on that, but you're going to do a way later on, week 4, you're going to do a thing called the nth root test, and we might end up using that property or this one up here. Yeah, this one here. So when that happens, I'm probably going to say to you, remember those 2 pieces of magic I told you about? Let's use them again, right? Here's some situations where that happens. That kind of covers that. And to finish with, I love this question, but unfortunately, they're asking us to find the limit of this sequence. And although I love this question, I'm going to do it with you. And the reason I'm doing it is that very, very few students actually get to do it on their own. So it would be kind of hard to leave you hanging there. So we want to find the limit of this sequence. And it's not clear what that is. Would you agree it's a weird looking sequence at the best of times? So the first thing I'm going to do is I'm going to set up a recurrence relation. And A1, the seed, is root 2. And then we're going to look at how you get from here to here. Well, isn't the next answer 2 times the previous answer inside the square root? Are you happy about the recurrence relation that generates this sequence? I looked at this guy and I looked at this guy and I noticed you multiplied it by 2 and then you found its square root. Now, if that works, do you see over here? Don't you multiply that one by 2 and then you put the whole thing inside the square root. So this does work. Okay, so I've got a recurrence relation. Great. Now I need to find the limit. What will I do next?
Limit both sides, right?
Okay. Let's see if we do. You remember we've done this trick before? I think that's what you meant, Matthew. I hope you did, right? Now, we'll assume that that has a limit, and don't we basically call it L? And this guy has a limit, and won't we call it L? And what you end up with then is basically an equation. So our job is to find L, isn't it? Okay, give me something to do to both sides that's going to get me closer to that answer.
Square both sides.
Sounds like a good move. Do what next?
Divide by an L.
That would work. What happens if L is 0? That would be a bad move, wouldn't it? So instead of dividing both sides by L, which actually in this case does get you the right answer, but in some situations it might not, what would be a safer way to approach this question? Don't overthink, it's pretty straightforward.
Subtract both sides by 2L.
Yeah, that's typically a safer thing to do in these questions. Now, how about factoring it? And that means that L could be 0 and L could be 2. And out of those two choices, 0 would only occur if I made the seed 0, right? If I made this 0, everybody would end up being 0. So I'm not using that one. There is our answer. Isn't that kind of cool? Any more questions about sequences and finding the limit of sequences?
I
Got
had
it good? Yeah?
it was number 28 on the home.
Okay, let me zoom back, find 28, see what weird stuff's happening with 28. 28 looks something like this guy. N squared. Oops. Try that again. N squared e to the negative 5n, right? So that's the sequence. That's good. And we're being asked to find the limit as n tends to infinity of that guy, right? And they give you a choice at the bottom, which I'm not too bothered about right now, because the answer is the fourth one. But we need to rewrite this in a format that allows us to do one of these. So this is one of the questions that you can actually do this method on. How would we rewrite this fella? Well, I would suggest that. Essentially, if I write it as a fraction, isn't it going to make L'Hopital the go-to guy? And you might say, well, why didn't I take the n squared and call it n to the negative 2 and put it in the bottom? Well, I could have done that, but the math would have looked really ugly and it wouldn't have been obvious when you tried to do the, plug infinity in at the end. It wouldn't be quite clear what was going on. This way does work much nicer. So if you take the limit as n tends to infinity on the top and on the bottom, and then you do L'Hopital another time, you get that guy. But when you make n infinity, you basically get 0. So the limit would be 0. And the choices would be use L'Hopital, define an equation, blah, blah, blah.
That makes sense. Thank you.
Okay. Any other questions before we continue? Last chance? Okay. let's move on then.
Can I see the last paper real quick?
There we go. Oh, maybe not. Yeah, okay. Not that I'm talking to myself here. I was about to do something, I changed my mind. Do you know the only reason I talk to myself, David?
Because we're silent.
No, it's because it's the only way to have an intelligent conversation. It's a joke. No. Okay. Say your last name for attendance, everyone. I've decided that this is kind of a natural stopping point. I don't want to start something, then tomorrow basically just start again. Seems a pointless exercise. Tomorrow we're going to do series. When you look at chapter 11, there's one section, 11.1, on sequences, and there's something ridiculous like 13 sections on the other stuff, sequences. So obviously sequences is bigger and better in a lot of ways. But that is tomorrow.